wheelchair I show you. And for example, I want to show you, you see the video, an obstacle avoidance or doorway crossing application. And the wheelchair here is 70 centimeter wide. And he's able to cross a doorway with 100% success if the doorway have 84 centimeters. Only 14 centimeters wider than the wheelchair. And what is important here is the user has only an on-off sensor, not a joystick, only an on-off sensor. Another application here is another wheelchair, but in a corridor. In this application, the user have only an on-off sensor too. Okay, I want to skip. It's not important, this information. Okay, as I said, it's a symbiotic architecture because the wheelchair, the robot part is a continuation of what the person wants to do. And the software architecture is a lot of modules, a lot of agents, behavior agents, environment agents, and cognitive agents. And all these agents are communicate with a shared memory in the center. And the agent, environment agent, are composed of the interface, of course, but also sensor and actuators. And in order to modify easily the environment or the sensors, the perception sensor, we have replaced this part with a simulator. A simulator, for example, a 2D simulator, for example here. You can see on the right, here center right, the interface activated by only an on-off sensor. There is a scanning system with a row in the center, and once a row is in the direction the person wants to follow, he activates the on-off sensor. Every time when the robot or the wheelchair stops, the person enters a new direction with this scanning system. I want to wait the end of the video because I want to show you something. It's going to this doorway on the bottom. Yeah. It's finished now. Okay. Here you can see a lot of points, different points with different colors. And each point represents one behavior. Each color is one type of behavior. Avoidance behavior, follow right wall, follow left wall, go back, go forward direction, for example. And you can see here the different behavior was output to the wheelchair. This is the coordination between the person and the wheelchair. And we have extended the simulator to a 3D simulator, three-dimensional simulator. And here you can see the person can move in a 3D, in a virtual reality environment. And this is very important because it is a transition to the next. Okay, I want to give you some statistics. Only about 10% of patients who receive a powered wheelchair find extremely difficult or impossible to use it in daily life activity. 9 to 10%. It's very important. And 18 to 26% of patients who use manual wheelchair should not handle an electric wheelchair. It's very important statistics, this. And we have a goal is to design a system in order to fit the wheelchair characteristics to the disabled person. The person have some disabilities, and what is important is to design the wheelchair that fit the best to the person. And the second point, to better determine the real needs and to target the commercial offer of the future, but the less important point is. And we want to use virtual reality in order to determine the wheelchair characteristics in order to be adapted to the different needs of the user. The methodology we used is virtual reality. As you have seen, we have replaced sensor and actuator by the simulator, and the simulator may be here the virtual reality. Why virtual reality? First, this technology allows to escape from any security aspect. There's no problem with security aspect. It's an answer to the statistic I show you. The second is to collect easier different information coming from the environment. It's no problems of the sensor misreadings, for example, information. And the third one is to allow more flexibility in choice, in the environment choice. You can modify the environment easily. These 3 points. And we have developed an environment which is a museum. Museum, you can see some picture here. So, system we have proposed. The architecture is based on 3 parts. The simulator with some initial conditions, with some environments, every time indoor environments. We are working only in indoor environments. And pathology database and different wheelchair, commercial wheelchair existing on the market. And this is a simulator. The second circle on the bottom is an evaluator. The person moves in the virtual environment and we get some information from the environment during the motion in this environment. And then with this information and some criteria, we propose what is the best characteristic, the best function we must to implement on this wheelchair in order that this person can use the wheelchair. This is a configurator, the third part. The simulator, I said you it is a museum, but in this museum there are some difficulties. For example, narrow corridor in the up part, the doorway, some doorways we want to cross, some obstacles on the environment the person must avoid. And the evaluator is based on a decision-maker system. This decision-maker system is based on fuzzy logic system. We start with a list of some situation, corridors, obstacle, to avoid a doorway crossing, some particular situation, and some behaviors. The same behavior I spoke about the first slide. And we must find some criteria that allows to identify any situation or behavior to apply. And then we must have a tool in order to find the best assistive answer to one situation or to one behavior. And here we use fuzzy logic technology. What are particular situation and behavior? Situation with collision, situation with blocking, person cannot go in the front or in the back, or behavior that qualify the driving, the quality of the driving. For examples, oscillation, or it's possible to stay parallel to the wall, for example. And we get some data from the environment, the position of the wheelchair, the time of each measure, range information coming from the sensor, or some semantic data. For example, you cross the door, you are in a corridor, some semantic, and so on. Some information coming from the environment. And we have some criteria. Global criteria and local, specific local criteria. Global criteria, for example, duration of the experiment, different stop number, for example, or collision beginning number, and so on. Some information, some criteria we use to compute the best behavior. And we make a reasoning, every time based on fuzzy logic. Fuzzy logic, for example, if you have some information about collision number beginning and average length of collision, that information could be big, small, and with this information we can find what is the best function, best characteristic to give to the wheelchair in order to cope with the difficulties, the capabilities of the person on the wheelchair. And we have done some result. Is a system which works in sequence. First experience, the person is on the wheelchair, basic wheelchair, and try to move in virtual reality environment. And then we get information, and the system says us that it's good to adapt to this basic wheelchair a backtracking function. And then we put virtually the backtracking on the virtual wheelchair, and the person goes in the virtual environment again. And then is the experience 2. And then we see that the person cannot avoid obstacle. And then we put, after the second experience, backtracking and obstacle avoidance. And the person go back in the virtual environment, and then we can see that this wheelchair is adapted to the person's difficulties. Yes, it's very interesting, but the person is moving. But why? Why to move? This is a good question. Why to move? You can see here in the video, the person wants to grasp butter, for example, in the refrigerator. The person is going in front of the refrigerator, opens the door,